What do we know about their machinery? What equipment do they have?
They lack a nucleus.
They lack a nucleus, okay.
Biconcave.
They're biconcave. What else do we know about them? They have no what else? No mito. They don't use what?
Oxygen. Or oxygen.
They don't use oxygen. Everybody needs energy. No mitochondria, no electron transport system, no O2. Okay, they do anaerobic glycolysis. Aerobic. Okay? So we know that about them. What else do we know about them? They are green. Okay, they're red.
Same.
But they are green. What makes them green? Yes, good. They recycle. Okay, what are we interested in? Okay, what dump do they go to?
The heart.
Oh, phagocyte.
The heart.
Right, macrophage. Okay. They recycle at a macrophage. One of the important things that gets recycled is iron, which goes to where?
That's into the bone marrow.
Yeah, at least for practical purposes, we'll take it back to the bone marrow. Okay, which bone marrow?
Right.
Red, okay. Okay, and this is to, create more hemoglobin. The next round of hemoglobin. Okay, and what takes it there?
Transfer.
Good. Okay, remember. Yes, transferrin transfers. Okay, transferrin transfers. Okay, what else happens? Bilirubin gets recycled. Where does it head to? I'm sorry? Liver. Good, you're good. I thought I heard you say it, wasn't sure. Okay, bilirubin heads to the liver. Where does it head after that?
Large intestine.
Okay, makes a stop at the gallbladder, right? Why?
Because the gallbladder stores.
Because, right, it stores and concentrates. Okay, so what am I thinking here? I'm thinking, okay, bilirubin. Where does it goes to the liver, it comes out in bile, it makes the stops along the way. So that's what I'm thinking. Okay, think like me. Okay? At least for Friday's test. Okay, so bilirubin goes to the liver, goes to the gallbladder, ends up in the intestine, right? Large intestine. Okay, ends up in your poo and you're done. Okay, hematocrit is what?
The percentage of blood.
That's red blood cells.
Whole blood volume of formed elements. Okay. So, hematocrit. We have our capillary tube. It's full of red blood cells. There is a buffy coat on top, which is what?
White blood cells.
Right. Okay, down here is red blood cells. What's up here? Plasma. Okay. Is plasma a formed element?
No.
No. Is plasma part of hematocrit?
No.
No. What's part of hematocrit? Red cells, white cells, platelets, formed elements. Okay. Good, good, good. Ejection fraction, which is near and dear to everybody at the moment. Okay, is a percent of EDV, what's EDV? Are the vents full or empty? Full, everybody say it. EDV vents are full, good. I would love for a mnemonic to pop into my head about that. Okay, so this is the percent of EDV going out in what? Stroke volume, good. Okay. Are you guys getting down to where like you're throwing stuff at your notes like this and just kind of reviewing? Okay, you need to be there, okay? Okay. I wrote this one and I'm sure glad I did write it as a test question this way because I would have had to. What I wrote was, do red blood cells go through a capillary? Yeah, kind of. You know? Okay. What I meant was, do they cross a capillary wall? No. Okay. No, they do not. Do they cross the capillary wall in a continuous capillary? No, they do not. In a fenestrated? What other kind of capillary is there? Sinusoidal? Okay. Does a red blood cell cross any of those capillaries? No. Okay. Myself on that one. Okay. What does cross here? No, so what am I thinking? I'm asking you a question about something crossing a capillary. What's on my mind? Plasma proteins, okay. What kind of capillary does that cross? Sinusoidal. Okay. Okay, so this lets plasma proteins cross. Are plasma proteins big or little in this world? Big, right? They are big. Okay, so is a plasma protein, we know they cross the sinusoidal. Does it cross the fenestrated? No. What might cross the fenestrated? Something bigger or smaller? Smaller. Okay, good. So like small peptides. Okay, are small peptides going to cross a continuous one? No. What will? Fluids. Yeah, something smaller. Right. Okay. How will oxygen cross? How will CO2 cross? Actually, CO2 is going this way. We like oxygen. Whoops. Yeah, we like oxygen to go the other way. Okay. Remember how they cross? Diffusion. They diffuse. You guys are good. Okay. So what I'm thinking here is, if I'm asking about a sinusoidal, it's going to let everything up to plasma proteins cross. It's not just plasma proteins. Okay, so that's what's in my mind. If I'm asking you what's crossing the sinusoidal, it's everything up to plasma proteins. A fenestrated, everything up to small peptides. Continuous, not a whole lot gets through there. Okay. Okay. What's agglutination? Okay, good. So you have like an A here and an anti-B here, and that's all good, but if you get an anti-A in, they agglutinate and they lyse, right? So you see that in red blood cells, you see agglutination. Okay. What guards sinusoidal capillaries? Men, which are? Right. The phagocytes guard these guys, because why do they need to be guarded? Because they're big, stuff can get in and out, right? Okay. BCOP. Oh, okay. Remember BCOP? COP over here, and CHP over here, and this is the arterial end, and this is the venous end. Okay, what makes this work?
Osmotic
Okay, high osmotic pressure. Okay, and this is, don't let me mess you up. This is inside the capillary, right? Inside the capillary, we have high osmotic pressure and high BCOP. Okay, so this is inside the capillary. Okay, so what gives us our BCOP? Right, formed elements of the blood, but we don't usually talk about other things as being necessarily formed elements, but plasma proteins are one of the big things that give us BCOP. Okay, so how do you want to think about that? You can think of like dehydration here. Okay, it's just a way to think of, I'm getting squinty eyebrows. Don't think of dehydration. But think about how if there was more hydration, there would be less BCOP. Okay, because here the fluid goes out, and here there's still the plasma proteins and all that stuff in here. So plasma proteins are one of the major things. And plasma proteins are what? What do we call that? When you have a solution with... Huh? Solute. Is that what you said?
Yeah.
Yeah, good. Okay. I'm up here where I can't hear, but I'm always where I can't hear. Okay, solute. Those are all solutes. So what am I thinking? Huh?
I was thinking that the node right there, above solute,
Oh, no belongs with, yeah, belongs over there. Okay, so solutes. So I'm thinking, you know, if I'm asking you about BCOP, I'm thinking about solutes, and I'm thinking about lots of solutes. Okay? This is all making sense? Boring? Okay? Good? Okay. We'll go with it. Net filtration pressure. Remember net filtration pressure?
Yes. CHP minus BCOP.
Okay, good. Let me take this out. Okay. So net filtration pressure equals what?
CHP minus BCOP.
Good. Okay, so here we have the arterial end, here we have the venous end, here we have a positive net filtration pressure. I should draw this inside too. I know that you guys can't do this with your notes. I'm terribly sorry. I suffered through many years of the same thing on the other side of the whiteboard. Okay, so we have a positive net filtration pressure there, and we have a positive CHP. Okay, and here we have a negative net filtration pressure and a positive BCOP. Okay?